The amendments to the Stormwater Management Rules found that NJAC in Title VII, Chapter 8, and the Flood Hazard Area Control Act rules, abbreviated as FACA, at NJAC 7:13, were adopted and published in the New Jersey Register on July 17th of 2023. The amendments address one of the major threats climate change presents. That is, the increased volume and intensity of rainfall events and the attendant effect of the additional runoff on stormwater management systems and flood elevations in riverine areas. First, this presentation will provide some of the history that led to the amendments, and then I will cover the two definitions that have been added to the rules, and after that, I'll go over the applicability to major development and discuss the legacy provisions, which are those projects subject to the prior rules under certain conditions. The legacy provisions will be followed by the change to the allowable calculation methods. After that, there will be a longer discussion of the multipliers to be applied to modify the NOAA's published rainfall data and how those multipliers are used in the calculations for groundwater recharge and stormwater runoff quantity control. After that will be some examples. I will also briefly review the other updates that have been made to the BMP manual, the FAQs, and the Municipal Stormwater Control Ordinance, which we abbreviate as SCO. Lastly, we'll have a Q&A session before wrapping up. And again, for those in attendance for just the rule amendment training, do not leave the meeting until I make the announcement to dismiss you. All right, so now for that quick history lesson on what led to the rule amendments and an overview of the studies involved. Executive Order 100 was signed by Governor Murphy on January 27th in the year 2020. This required that the DEP shall, within 2 years of the date of this order and consistent with applicable laws, adopt Protecting Against Climate Threats, PACT abbreviation, regulations. Furthermore, it required the DEP integrate climate change considerations such as sea level rise into regulatory and permitting programs, including, but not limited to, land use permitting, water supply, stormwater and wastewater permitting and planning, air quality, and solid waste and site remediation permitting. Subsequently, Administrative Order 2020-01 was signed by then Commissioner McCabe to integrate climate change considerations and so forth into the DEP's regulatory and permitting programs. In accordance with the executive order, the department conducted research and underwent several stakeholder meetings beginning in 2019, first as part of the PACT rules and then again independently in October 2022. The department released a New Jersey scientific report on climate change in 2020 and reports on rainfall studies in 2021. All of these were in preparation to address the impacts of climate change, which then led to the proposal on December 5th of 2022 and adoption on July 17th of 2023 of the Inland Flood Protection Rule. The reasoning behind the rule amendments is based on the scientific studies showing the data used for the design of stormwater infrastructure is outdated. It no longer reflects what is happening in our state, so much so that in November of 2021, the Northeast Regional Climate Center, which is a partner with the National Oceanic and Atmospheric Association, abbreviated as NOAA, and the DEP, released studies showing that the 2, 10, and 100-year storms have all experienced increases in rainfall depths since 1999. Furthermore, reasonable predictions based on this information show that this will only worsen over the coming decades. The areas with the darkest shading in this graphic are anticipated to have 100-year storms that will increase between 141 and 150% by the end of this century. More rainfall means more runoff, which means larger discharges, and we will also see more flooding as a consequence. Additionally, global warming increases both the energy in the atmosphere and the potential for more intense storm events. The science predicts that these storms will occur more frequently and at higher intensities than those of the 20th century. And I'll cover this a little bit more in a little bit. We've experienced quite a number of major flood events since the year 2000. Several of those flood events are listed on this slide. In many locations, stormwater runoff is often discharged off-site, and with the increasing intensity and rainfall depth, this will stress our infrastructure, such as bridges, roadways, and stormwater management systems, and will create further problems down gradient of the discharge points. This, in turn, increases risks to the inhabitants and properties. Keep in mind, New Jersey is the most densely populated state, and most of the population centers are in the floodplain. So adding climate change on top of worsening flooding is just going to compound the issue and make things unsustainable. NOAA's rainfall precipitation and intensity data published in Atlas 14, Volume 1, or on NOAA's Precipitation Frequency Data Server is essential to stormwater management designs. However, the precipitation depths and intensities were based on data collected from weather stations ending in the year 1999, meaning the design doesn't really reflect the precipitation that we're experiencing today. Add to that runoff from older sites where there was no stormwater management, and the impacts worsen, potentially wiping out infrastructure and putting people in danger. Climate change will continue to bring more intensive rain in the future. A stormwater best management practice, or BMP, as we like to abbreviate it, has a long service life, and BMPs designed in accordance with outdated rainfall data will become insufficient to handle the increasing precipitation depths and intensities. Therefore, there's a real need to anticipate the increase of precipitation depths in anticipation of the effect of climate change and use the predicted precipitation depths to design stormwater BMPs. The adopted rule amendments are what is required to address those impacts. The stormwater management rules at NJAC 7:8 were amended to address the role of climate change in BMP design. So first, I'm going to provide you with a guide as to which subsections were amended. So we'll start with subchapter 1, and I've underlined the subsections where the rules were amended, namely subsections 1.2 and 1.6, and I will discuss the details of those changes momentarily. But on this slide, as you can see, this is the layout for subchapter 5 in the rules. So within this subchapter, the rule adoption amended only the underlined sections, namely 5.4, 5.6, and 5.7. The details of those changes will be discussed a little bit after I discuss those for subchapter 1. Okay, in the amended rules, there are two definitions that have been added regarding public transportation projects that are subject to the rules in effect prior to this rule adoption, which will be dependent upon when the public transportation projects achieved a certain status. So first, by public roadway or railroad, we mean a pathway for use by motor vehicles or trains that is intended for public use and is constructed by or on behalf of a public transportation entity. A public roadway or railroad does not include a roadway or railroad constructed as part of a private development, regardless of whether the roadway or railroad is ultimately to be dedicated to and or maintained by a governmental entity. By public transportation entity, we mean a federal, state, county, or municipal government, an independent state authority, or a statutorily authorized public-private partnership program pursuant to public laws from 2018, Chapter 90, known as NJSA 40A, in items 11 through 52, and so forth. that performs a public roadway or railroad project that includes new construction, expansion, reconstruction, or improvement of a public roadway or railroad. So note that a public transportation entity includes municipalities and counties that perform public roadway or railroad projects, but does not include the roadway within a private development, but dedicated to the municipalities or counties or to be maintained by the municipalities or counties. Up next, we're going to look at the applicability section of the amended rules. First of all, the applicability section indicates that a major development that doesn't fall under item B is subject to the rule amendments. Going forward, we're going to refer to item 1.6B as the legacy provision. Secondly, a major development project that does not meet those permits listed in section 1.6C, which are a flood hazard area, freshwater wetlands, a CAFRA, a waterfront development, or a highlands permit from the department, and has submitted an application for the approvals listed in Romanets 1 through 5 prior to July 17th of 2023 will not be subject to this rule adoption. A complete application means that the application submitted to the municipality has all of the required documents specified in the municipality's ordinance, and the municipality's reviewer considers the application complete for the review of the stormwater management design. So take note that the application and all accompanying documents shall include the documents for stormwater management. If the application submitted to the municipality for those approvals did not include the design documents for stormwater management, the legacy provision here will not be applicable. Item 2 in this section establishes the timeframe for projects subject to the rules in effect on March 1st of 2021. Again, provided it included all of the required materials I just discussed. Similarly, the same goes for item 3, except the rules are those in effect on March 2nd of 2021, the GI rules, and projects are also subject to the same conditions regarding the items submitted. Okay, so now for item 4, which is for projects submitted to the department. If a major development project needs a flood hazard area, a freshwater wetlands, a coastal areas facilities review act, a waterfront development, or a highlands permit, and those permit approvals need a stormwater management review component, is technically complete, and has been submitted prior to July 17th of last year, it is subject to either the rules in effect on March 1st of 2021 or the rules in effect from March 2nd of 2021 through July 16th of 2023, depending on when it was submitted. And of course, provided everything required by the department's rules for those permits, plus the application form, were submitted prior to July 17th of 2023. Lastly, technically complete means that each item included in an application provides sufficient information for the department to declare the application complete for review, public comment, or public hearing. So these are those department permits I mentioned earlier, along with where they are found in the New Jersey statutes. Moving on. Exemptions expire with the expiration, termination, or other loss of duration or effect of either of the qualifying local approval or department permit, whichever comes first. The expiration of local approvals under B1 on the previous slide shall be governed by local ordinance. In the event there are multiple qualifying department permits under C, which I read previously, the expiration date is governed by that permit which expires last, provided that the permit is still in effect. Once the exemption expires, the major development shall be subject to all requirements of this chapter upon reapplication for that permit and all subsequent permits or local approvals under the municipal land use law. And there's one more citation for limits on these exemptions. And this next bit's really important. The aforementioned exemption is limited to the land area and the scope of the project addressed by the qualifying applications or subsequent approvals. The review agency will consider the impacts from any revision, including but not limited to the items listed here, and may deem the exemption void if the revisions do not have a de minimis impact. An additional legacy provision exists for certain public roadway and railroad projects and is found at NJAC 7:8 under 1.6F. Public transportation entities must demonstrate that the project has determined a preferred alternative or has reached an equivalent milestone prior to the rule adoption. The logic is that these projects have already undergone a significant level of planning and design, such that revising the project now to meet the rules would be a waste of public funds. So next are 4 examples to help clarify the applicability portion of the rule adoption. To start off, I have 2 examples for projects where a department permit is required. For example, number 1, a non-residential major development submits an application for the department's Flood Hazard Area Control Act permit with the stormwater review component on August 1st of 2023 and is deemed technically complete. The non-residential major development also submits an application to the township for a preliminary site plan approval on August 1st of that year, but the township's stormwater control ordinance is still in alignment with the rules in effect prior to the July 17th, 2023 amendments. What rules and SCO are applicable to this non-residential major development? Well, the department will review the stormwater component of the application under the adopted rules. Therefore, the non-residential major development shall design its stormwater management in accordance with the adopted rules. However, the township will review the stormwater management under its SCO pursuant to the prior rules. Since the design complying with the adopted rules is supposed to be more comprehensive and has a higher capacity than the design under the prior rules, the design under the adopted rules should be able to pass the SCO pursuant to the prior rules. And for the second example, we have a non-residential major development submitting an application for the department's flood hazard permit with the stormwater review component on June 1st, 2023, and it too was deemed to be technically complete. Now, in this case, the non-residential major development also submitted an application to the township for a preliminary site plan approval on December 1st of 2023. By this time, the township stormwater control ordinance had been amended to be consistent with the rules adopted on July 17th of 2023. And so which rules or SCO are applicable to this non-residential major development? Well, the department's going to review the stormwater component under the prior rules. However, the non-residential major development will need to redesign its stormwater management to comply with the township's SCO pursuant to the adopted rules. All right, receipt of the department's approval on the stormwater management design does not necessarily secure the township's approval. The township's reviewer shall apply the township's SCO pursuant to the adopted rules when reviewing the stormwater management of the proposed project. So this example is different, all right? In this case, the permit came into the department before the rule adoption, but the project wasn't submitted to the municipality until later that year, and by then the municipality had updated its SCO. Okay? All right, so now 2 examples which a department permit is not required. All right, so example 3. A non-residential major development submits an application to the township for a preliminary site plan approval on December 1st. of 2023, but the township's SCO is still in alignment with the rules in effect on July 16th of 2023. The project will not require any of the department permits that were listed under subsection 1.6C in the stormwater management rules. Is the project subject to the amended stormwater management rules? Well, the township will review the stormwater management under its SCO pursuant to the prior rules, provided the submittal includes all of the required documents prior to the township amending its SCO pursuant to the July 17, 2023 amendments made to the stormwater management rules. So pursuant to the requirements of the MS4 permit, the township must revise its SCO to align with the amended rules and have it be in effect within 1 year of the rule adoption. Okay, so we're about 2 months and a few days away from that time limit. Okay. And now for our last example, a non-residential major development is submitted to the township for preliminary site plan approval on December 1st of 2023, and by then the SCO had been amended to be consistent with the rules adopted on July 17th of 2023. So also no permits required from the department. So is the project subject to the amended stormwater management rules? Well, the non-residential major development will need to design its stormwater management to comply with the township's SCO pursuant to the adopted rules. The township's reviewer shall apply the SCO pursuant to the adopted rules when reviewing the stormwater management for the proposed project. Okay, next up is the amendments for subchapter 5, which is the design and performance standards for stormwater management. All right, just so you know, going forward, this red stripe is specifically for subchapter 5 of the stormwater management rules. Now, there's no changes to subsections 5.1, 5.2, stormwater management measures for major development, 5.3, green infrastructure standards, 5.5, water quality, 5.8, maintenance, or 5.9, technical sources, but I'm going to handle the remainder of the subchapters out of order, starting with 5.7, the computational methods, as this impacts the remaining subsections I've yet to discuss. So there is a change in the allowable computation methods, namely only the NRCS methodology is found in the adopted rules. So that means the NRCS methodology must be used when calculating the water quality design storm. And throughout the remainder of this presentation, I'm going to do my best to give you page BMP manual, and this information is included under item 13 on page 32 of chapter 5 in the BMP manual. Okay. The NEH is available at the link, but you know what? There might be a problem with this link. If there is, we will put the proper one into the chat. So what this means is that you may no longer use the rational method nor the modified rational method to calculate stormwater runoff, whether for groundwater recharge, stormwater runoff quantity control, or water quality. The rationales and the justifications to eliminate the rational method and modified rational method are addressed in the rule adoption notice that was available or is available on the department's website. I'm not going to repeat them here. All right, but just to note, the rational method is still applicable for storm sewer or drainage system designs pursuant to the residential site improvement standards under NJAC 7:21, subsection 7.2 C5. So when using the NRCS methodology, slope, cover condition, and precipitation depths are the parameters we need to know to perform those calculations. So let's talk about the requirements for the precipitation depths to be used in our calculations. So the rule amendments require calculation to be based on 2 different precipitation depths calculated by applying multipliers to the outdated rainfall data. Okay, the first set of precipitation depths to be used will adjust the 1999 rainfall data to the year 2019 for the 2, 10, and 100-year design storms, which is what the amendments mean whenever the current design storms are specified. Okay, to the right is a reprint of Table 5-5 from the rules. So to denote the adjustment of rainfall data to the year 2019, the precipitation depth we will use for the 2-year storm for a project in Warren County, okay, down here, is 102% of the depth listed on the NOAA PDF server for the 2-year storm. For the 100-year storm in Warren County, the rainfall depth is adjusted to 115% of the 100-year rainfall depth found on the NOAA PDF server. So the first example that I will present will illustrate the calculation of the current precipitation rainfall depth for a site. And if you aren't familiar with using the NOAA PDF server, start on page 12 of the revised Chapter 5 in the B&P manual published last July. Now, for a site that's in more than one county, you will multiply the rainfall depth from the first area by the county-specific current precipitation adjustment factor for the design storm you're looking at, and then multiply that product by the percentage of the total area lying in that first county. You repeat this method for the second area, but in this case, you are using the current precipitation adjustment factor for the second county for the same design year storm, and then you're going to multiply that product by the percentage of the total area located in the second county. Then you just sum those two to get the current adjusted total rainfall depth for that design storm. All right, Chapter 5 in the B&P manual has an example. It's numbered B-1, and it's found on page 18, and it depicts the site situated in 2 counties. Now, I mentioned the PDF server data, but you can also use the county 24-hour rainfall data from the NRCS, and then you apply the current precipitation adjustment factor from Table 5-5 in the rules. The county-specific 24-hour rainfall frequency data published by the NRCS in the 2012 Engineering Field Handbook is reprinted as Table 5-1 on Table 15 of Chapter 5 in the B&P manual. There's a second multiplier required in the rule amendments, and applying the future precipitation change factors to the published NOAA rainfall data will allow us to look ahead to the period from the year 2050 through 2099 to address the future impacts of climate change. So when the rule amendments call something the projected 2, 10, or 100-year design storm, this particular calculation is what is needed. So to the right on the slide is a reprint of Table 5-6 from the rules. So what this means is that the precipitation depth we should use for the projected 2-year storm for the same project located in Warren County is 120% of the depth listed on the NOAA PDF server for the 2-year storm. For the projected 100-year storm in Warren County, the rainfall depth is adjusted to 137% of the 100-year rainfall depth found on the NOAA PDF server. And of course, for a site that's located in more than one county, it's the same method as from the bottom of the previous slide, but in this case, you use the future projected change factors from this table. You multiply the rainfall depth from the first area by the county-specific future precipitation change factor for the design storm specified, and then multiply that product by the percentage of the total area lying within the first county. You repeat this for the second area using the future precipitation change factor for the second county for the same design storm, and then you sum these products to get the future projected total rainfall depth for that design storm. And don't worry, I'll have examples, okay? So let's move on. We also have to talk about time of concentration calculations, as the equation uses the rainfall depth resulting from the 2-year design storm event. All right, so although how to calculate the travel time of runoff in sheet flow is not explicitly stated in the rules, it's because the rules require using the current and projected 2, 10, and 100-year storm events in the stormwater calculations. The 2-year storm event used in the calculation of the travel time of sheet flow shall also use the current and projected 2-year storm events respectively. So time of concentration for the current storms will use the current rainfall data, meaning you multiply the NOAA rainfall depth for the 2-year storm by the current precipitation adjustment factor. However, for projected storms, be sure to multiply the rainfall depth for the 2-year storm by the future precipitation change factor. Of course, if you're dealing with very small areas, there won't be much difference, but there will be for larger drainage areas. Okay, so one other thing I must mention is that the rainfall depth of the 2-year storm P sub 2 that's used in the calculation of the time of concentration for the water quality design storm is based on using the projected 2-year storm event. Okay, now it's a lot to remember. All of the information is found on page 25 of chapter 5 in the revised BMP manual. Okay, so now that I've explained by what the rules mean by a current or projected design storm, we can go back to subchapter 5.4 in the rules. So for groundwater recharge, the rules allow you the option pursuant to NJAC 7:8-5.4B1 dot Romanet 1 to address the loss of recharge on an annual basis, and that is done through the use of the groundwater recharge spreadsheet. Nothing changed for this option. However, if you're going to infiltrate the difference between the pre and post construction runoff volumes, you must do so as required under the second option shown here, using the projected 2-year design storm. Remember, the projected 2-year storm uses the future precipitation change factors found in table 5-6 in the column for the 2-year storm. So, in other words, the design looks at what would happen if nothing on the site changed versus what the site changes are proposed and their impacts at 2019 and in the future. Okay, for these, you may find that the examples 5.6, 5.7, and 5.8 in chapter 5 of the BMP manual are helpful on this subject. One other thing is that chapter 6 of the BMP manual has been updated to match the rule adoption. Okay, now for the stormwater runoff quantity standards, which are found in subsection 5.6 of the rules. So there's 3 options from which to select in order to demonstrate compliance with the requirement to control stormwater runoff quantity impacts. So under the bullet is the rule text for the first option to demonstrate compliance with the stormwater runoff quantity standards. Okay, note that the bold or yellow text is the portion of the rule that has been amended in the adopted rules. Okay, so remember, section 5.7C was covered on slide 25 and 5.7D was covered on slide 26 respectively. The bolded text will be discussed after we look at the other options for demonstrating stormwater runoff quantity control compliance. So here's the rule text for the second option to demonstrate compliance with the stormwater runoff quantity standards. So as on the previous slide, the bold or the yellow text is the portion of the rule that has been amended in the rule adoption. Lastly, this is the rule text for the third option. As before, the bold or yellow text is the portion that was amended in the rule adoption. Okay, so regardless of which option is selected, the quantity control calculations required will have to include an analysis of runoff volumes produced for both the current and the projected design storms. So you will review the pre-construction, aka existing conditions, and what's proposed using the rainfall data to which the current precipitation adjustment factors are applied to do your comparison using numbers that reflect what was precipitating in 2019. You also have to review the pre-construction conditions and what's proposed using the rainfall data to which the future precipitation change factors are applied to do your comparison using numbers that will reflect what will be happening from 2050 through 2099. That way, your review checks that the designs work for what's currently precipitating and what we can expect will precipitate due to climate change. If you recall, I covered the time of concentration calculations on slide 27, but they also come into play here. So if you're using modeling software to design or to review the accuracy of designs, you may want to create a model for the projected storms that is separate from the model for the current storms because of the different rainfall depths. Okay, and you may also want to look at page 84 in chapter 5 of the BMP manual, which has the updated summary of modeling guidance. All right, so let's pause for just a moment. At this point, everyone, you're going to need to remember the code that I have shown on this slide for when we take attendance later today. I'm going to read it to you. It's Arabic numeral 727, followed immediately by the letters S as in Sam, R as in Robert, A as in Adam. 727 SRA. Although I said this at the beginning, I will repeat it for those of you who joined us late. You will need to make sure you enter this code into the survey during the time we allot to take the survey when we provide the SurveyMonkey QR code or the link to be marked as complete for this presentation. Please write this code down now as it will be removed from the chat in a little bit. Please do not retype the code into the chat nor share the code with others. Retyping or sharing the code will result in a forfeiture of your attendance. Okay, are we ready to move on to the examples? Okay, so I have 5 examples for you today. The first is applying the current precipitation adjustment factors to a site located in just one county. The second is for a site partly in one county and partly in another. And the third is the comparison of the hydrographs from pre and post development conditions for the projected and current storms when impervious cover is reduced in the proposed design. The fourth will show how a design using a small scale BMP will meet the groundwater recharge requirement. And the fifth is sizing an MTD using the NRCS methodology. So for the first example, we're going to apply the current precipitation adjustment factors to the rainfall data for a site located at Trenton Station 2 on the NOAA NWS PFDS website. So we first go to the website found at the link shown. And in the data description section from the data type drop-down menu, make sure precipitation depth rather than precipitation intensity is selected as shown on the left. Similarly, for the time series type, ensure partial duration has been selected from the drop-down menu. Next, in step B, under the select location option, manually enter the location using one of the options offered on the screen, or use the map to locate the site, making sure to zoom in. So we're looking for Trenton Station 2. Right, next, scroll down the web page to the Point Precipitation Frequency or PF Estimates section. Left click on the PF Tabular option if it doesn't appear on top of the other tabs. And those other tabs will be shaded in dark blue since they're in the background. All right, the data needed is found in the row labeled 24 hour. The values in the columns labeled 2, 10, and 100 correspond to the rainfall depths generated by the 2, 10, and 100-year design storms respectively for this location, as outlined in red in the top graphic. Next, go to Table 5-5 in the rules and look at the row for Mercer County. So to obtain the current precipitation depth for the 2-year design storm, multiply the NOAA precipitation depth for the 2-year design storm, which is 3.3, by the 2-year current precipitation adjustment factor of 1.01 to get the 2-year current rainfall depth of 3.36 inches. That's shown in the column on the right in the bottom table. Repeat the process for the 10 and 100-year design storms using the proper adjustment factor. So that's how you get a 10-year current rainfall depth of 5.09 inches and a 100-year current rainfall depth of 8.48 inches, as depicted in the column farthest to the right in the table. So if you aren't familiar with using the NOAA PDF server, start on page 12 of the revised BMP manual, chapter 5, published last July, for more details. So for the next example, when a site is situated in 2 counties, the method is to obtain the current adjusted rainfall depths for each of the 2 counties and then weight average them based on the area of the site in its respective county. So here the site is located on the county line shared by Middlesex and Mercer counties. 1/3 of the site is in Middlesex and the remaining 2/3 is in Mercer County. So in step A, we obtain the NOAA data and the current precipitation change factors and calculate the rainfall depths for each of the design storms for each of the counties. Then next, as shown in the second table, we multiply the percentage of the project area within each county with the current precipitation for the respective county from step A, and then we sum the results for each of the design storms. And the final current precipitation depths are in the bottom row of the lower table. This example provides a scenario showing noncompliance with the requirements when the proposed development reduces the regulated motor vehicle impervious surface and increases the slope of the surface. So often for redevelopment projects, a designer would choose the option at NJAC 7:8 5.6B1 to demonstrate for compliance for quantity control that for stormwater leaving the site, post-construction runoff hydrographs for the current and projected 2, 10, and 100-year storm events as defined and determined pursuant to NJAC 7:8 5.7C and D respectively do not exceed at any point in time the pre-construction runoff hydrographs for the same storm events. So for a site located in Trenton, which is Mercer County, an approximately 2-acre paved parking lot is to be redeveloped as an office complex consisting of a new building, a parking lot, and landscaping. The existing lot has a slope of 1%. The redeveloped site will be regraded to a 5% slope for better drainage. The landscaped area will not receive runoff from the impervious surfaces. Hydrologic soil group C soils are present. Okay, so what we're going to do next is look at the calculations for the projected 100-year design storm. So a summary of the results from the modeling software is shown in the table. So to correctly calculate the time of concentration, first P sub 2 was calculated by multiplying the NOAA rainfall depth for the 2-year storm of 3.3 inches with the future precipitation change factor of 1.16 for Mercer County, and P2 is found to be equal to 3.86 inches. So here in the table is the summary information, and it looks like the results for the post-construction condition are less than that for the pre-construction values. Okay, so Next thing the modeling software does is it produces hydrographs with the peak flow rates and time intervals exported as data for input into a spreadsheet to create a chart. So although it's not shown here, at first glance, the hydrographs seem to show compliance, meaning the post-construction volume looks like it is less than that for the pre-construction condition. All right, we would think that the post-construction hydrograph would be completely under the pre-construction hydrograph. However, when we look at the data, we find that this is not the case. A zoomed-in view of the pre- and post-condition hydrographs are provided on the slide. So even a reduction in impervious cover should be reviewed to check the adjustment or change factors that have been correctly applied to the appropriate storm calculations and the data itself examined instead of the hydrographs to confirm that there are no exceedances. You would similarly inspect the data for the other projected and all of the current design storms to look for other instances where the post-development hydrograph exceeds the pre-development hydrograph. All right, detailed information for this example, all right, is available starting on page 41 in chapter 5 of the BMP manual. So this example provides a scenario showing the groundwater recharge calculations. Here, a 2.5 acre wooded lot is located in Somerset County. The latitude and longitude of the site are 40.4573 degrees and negative 74.5309 degrees respectively. The proposed development consists of a 1 acre office building, a half acre parking lot, and a half acre lawn area, plus 1/2 acres of existing woods to remain undisturbed. We're going to design a stormwater management system to meet the stormwater management rules. The soil present on site is HSGB. So we're going to assume that a small-scale infiltration basin is to be designed to meet the design and performance standards for the demonstration of the groundwater recharge requirement by infiltrating the increase in the stormwater runoff from pre-construction to post-construction for the projected 2-year storm, and we're going to calculate the volume of runoff to be recharged. So I'm going to skip the parts of the design calculations because I just want to focus on the groundwater recharge requirement. So for this site, I've included the NOAA rainfall depth, the future precipitation change factor for Somerset County, and the depth of precipitation for the projected 2-year design storm. So with a precipitation depth of 3.93 inches, the projected 2-year design storm will produce an increase in runoff volume for the post-construction condition, which is 17,886 cubic feet as shown in the lower table. So to comply with the rule requirement, this is the target that the design must achieve, provided everything else is designed in accordance with the BMP manual. Okay, so the fifth example is sizing a manufactured treatment device using the NRCS methodology, since we can no longer use the rational method and modified rational method for stormwater calculations. This example will walk you through what is now required. Okay, so we're going to calculate the peak flow rate for sizing an MTD to treat the water quality design storm from a 1/4 acre impervious motor vehicle surface. All right, the parameters that apply are we have an area of a 1/4 acre. Our slope is 5%. We use CN value of 98 since it is 100% impervious. We've determined that our projected 2-year rainfall depth is 3.84 inches. And we also need to make note that the hydraulically most distant point to the inlet of the MTD for our site is 110 feet. Okay, when using the NRCS methodology, you're going to need to calculate the time of concentration, for which we follow the method that's covered in example 5-1 of chapter 5 in the BMP manual. That example is found beginning on page 33. Okay, it's also the formula that we stated on slide 27. And as I said earlier, we use P2 for the projected 2-year storm in the TC calculation that we will use for our water quality design storm. However, there really won't be much difference here if we mistakenly use the current 2-year storm for our P2, given that we're only dealing with a drainage area of a 1/4 acre. Okay, then we have to calculate the maximum sheet flow length using the formula for the McEwen-Speece limitation that's found on page 24 in Chapter 5 of the B&P manual. And in this case, it's equal to 909 feet. However, the maximum sheet flow length should not exceed either, whichever is greater, meaning 100 feet limitation or the McEwen-Speece. Okay, so we're going to use 100 feet. All right, I'm sorry, whichever is shorter. All right, so we use 100 feet. Okay, 909 is way too long. All right, for our stated flow path length of 110 feet, okay, we have 100 feet as sheet flow, and that leaves 10 feet of shallow concentrated flow. Plugging that all in, T sub C is calculated to be 0.8 minutes. Now, we also have to use the SES, Standard Dimensionless Unit Hydrograph, with a shape factor of 484. This is also covered, and you'll find it on page 27 of Chapter 5 of the B&P manual. So with all of this together, the modeling software calculates that the peak flow rate for the water quality design storm is 0.77 cubic feet per second. So the next thing that we would have to do is determine the size of the MTD. And the selection of a model of a specific MTD listed on our webpage is based on the maximum treatment flow rate, or MTFR, for a hydrodynamic type MTD, or the maximum allowable drainage area evaluation method and the MTFR evaluation method per the certification letter for a filtration type MTD. Okay, go to chapter 9.5 for green infrastructure MTDs, and go to chapter 11.3 for MTDs that are not certified as green infrastructure for this calculation. Okay, so that should wrap it up for the examples, but please, there's a lot more information in chapter 5, and I would love for you to check that out. Okay, so now I'm going to move on to talk to you about the B&P manuals that have been updated. They are these listed here, and also we have updated and overhauled the frequently asked questions to address the various issues. So here's some screenshots from the updated B&P manual webpage. And of course, as usual, everything that gets updated gets those red stars, okay? So just look for all the updates. The FAQs have been expanded to address various issues, some of which have been mentioned on the earlier slides. The newest FAQs are on the bottom of the web page, above the blue footer. Just look for the rule adoption date and click on a question, and it will expand to show the answer. Okay, now the updates to the Stormwater Control Ordinance align with the rule adoption. They can be downloaded from our website in Word or PDF formats. So on the left is a screenshot from the updated website showing all of the different types of items available to download. There's a clean copy, plus there's a strike-through version to illustrate where text has been removed. And for those, the new text appears in red. And then there's the simplified version. And that one just cites subchapter and section numbers from the stormwater management rules instead of the full text to reduce or eliminate the need for municipalities to revise their ordinance when the stormwater management rules are amended. So a municipality has to comply with the applicable laws and procedures for passage and adoption of ordinances pursuant to this simplified version. All right, now, reminder, municipalities must amend their stormwater control ordinance within 12 months of written notification by the department of the need for modification and update. Notification was sent on July 17th of 2023, and as I said before, we're getting pretty close to that deadline. All right, on the lower part of the slide is a summary of the updates made to the SCO, okay, that match with the rule adoption, just so you can tick them off in your mind. All right, and we've also updated the hyperlinks throughout the documents and cleaned up their appearance. All right, so we're not done just yet, so please do not leave. All right, we're going to recap the adoption part of the presentation. All right, we added 2 definitions, and then after that, I covered the applicability to major development and discussed the legacy provisions, which are those projects subject to the prior rules under certain conditions. Now, it's also very important to remember that there's been a change to the allowable calculation methods, and I covered that. And after that, we had a little.
Tomorrow? No, I'm on. It's a Zoom, but it's on. I heard.
After that, there was a longer discussion of the multipliers to be applied to modify NOAA's published rainfall data and how those multipliers are used in the calculations for groundwater recharge and stormwater runoff quantity control. I know I went through them quickly, but I hope that you found the examples helpful. And of course, there's more in Chapter 5 of the B&P manual. In fact, go to page 33 in Chapter 5 of the manual, and you'll find a table listing all of the different examples. Okay, I also touched on the other updates made throughout the manual to the FAQs and the SCO. All right, so this is our contact info. We're not done. Don't leave. There's more. Okay, the video and slides will be made available for you to download for reference. So please continue to periodically check our website for updates to the manual and to the other stormwater related material. All right, and at this point in time, if you're not seeing the July 2023 date on the page or something more current, you need to refresh your browser. All right, we will move on shortly to our Q&A session, but it's time to take attendance. Okay, this is the QR code for you to scan with your smartphone. Now, if you would prefer to use the link, be sure to open either in another device or in another window or tab so that you aren't accidentally booted from the training. Please do not type the code that we gave previously into the chat or share it with others. That will forfeit your attendance status. This survey will only be available for a short time. All right, and in order to be marked complete for today, you must enter the alphanumeric code exactly as I displayed earlier, the one I told you to write down, where and when requested in the survey. And if you are watching this presentation with a group, each individual must complete the survey on their own. There's also going to be a place to enter professional engineering license information for those engineers seeking continuing professional competency credits. We're not able to offer credits for other types of licenses or certifications. The survey will be open for the next few minutes. At what time will we be closing the survey?
We will give everyone 5 minutes to finish the survey, attendance survey. And since today's schedule is pretty tight, so if you have any question, please type in the chat so we can continue our presentation. So the survey would attendance survey would be closed at 2:07. Thank you.
And if you're experiencing any difficulty opening the survey link, send an email right away. I mean, now, before that time has expired, to the email address shown here, okay? All right, with your alphanumeric code that we displayed and your PE license number if you just need CPC credit, okay, before 2:07 p.m. If we don't receive the correct code by the closing of the survey, we cannot verify your attendance and confirm your completion of the rule amendment training. Okay, if you're done with the survey, take a real quick break and come back by 2:07. This slide will remain up for now. Victor Z, I see you have your hand up. Are you having trouble with the survey? If you can't do the survey using the Survey Monkey, time's running out to send that email. Quick, quick, quick. The code is not case sensitive, just, I told you what it was before. Just no spaces, no hyphens, just 3 numbers, 3 letters.
Once we finish the survey, we can head out.
Not just yet. I have to run attendance one more time.
Sounds good. Thank you.
All right, time is running out. We need that email sent to the dwq-bnpc-stormwater-management@dep.nj.gov if you were not able to use the Survey Monkey.
Will we get a confirmation email? I finished it, but I didn't get anything in the email.
I don't have a setup for a confirmation email at the moment because I'm presenting.
Okay.
Sorry.
Well, I just assume it through then.
Yes, if you see you submit a survey, we will receive it. We don't
Okay.
send out the confirmation email.
Okay.
Thank you.
All right, thank you.
Changyi, it's 2:08 p.m.
Let's continue the presentation, and we will post the email address. If you cannot access the survey, you can email the attendance code to the email address we just post on the chat. So please continue the presentation. Thank you.
Okay, so what we had planned was a Q&A session. All right, so you're welcome to stick around for this. It's recommended. Changyi will lead the session off, or you can type them into the chat, or I see we have quite a few hands raised. All right, and so our plan was to dismiss you after the Q&A session so that would denote when the rule amendment training portion had concluded. If you can stick around, it might be helpful. Changyi, are you ready?
There's no Q&A for this one presentation. We
Okay.
move on for next one. Thank you.
All right. Peter, if you would please take the attendance report. So please feel free to email us if you think additional requests, if you have additional questions regarding the rule amendments. And thank you very much for attending. All right. We'll work on getting out the certificates for the people who did the rule amendment training shortly. All right. So if you signed up for SwimDer, you must stay with us going forward into the second half of this presentation to be marked complete for the module. All right. Now, the time is 2:11. So if you are only taking the rule amendment training, thank you for sticking with me until now. And just the rule amendment training people are dismissed and may leave the Teams meeting. Okay, so up next, we will continue with the SwimDer training in just a moment. As was pointed out to me, my agenda was not quite right. We actually have two examples. I think I said two, but I only showed one on the screen. Anthony will give us the GI fact sheet and example one. Please stand by while we switch over to Anthony.
All right, thanks, Lisa. Good afternoon. So we'll continue on with our regular scheduled presentations for Module 4, since that concludes the amendment training. So let's go ahead and get started with this presentation. The earlier modules introduced green infrastructure and some of the regulatory requirements around it. Today we'll start a review of the GI fact sheet, which you can find on our website. And this is in an effort to help better understand the rule requirements and how designs should meet them and what to check for in your reviews. Then we'll go over an example that incorporated GI into the design, and we will evaluate whether or not it follows what's spelled out in the GI fact sheet. Okay, so let's begin with the GI fact sheet. So this part of the presentation will answer the question shown on the slide here. To get right the first question, we covered in Module 1 what we mean by green infrastructure, which we abbreviate as GI. Dr. McGee also spoke about GI MTDs in Module 2, and Module 3 also included GI. To reiterate, a GI BMP is a stormwater management measure that manages stormwater close to its source by either 1, treating stormwater runoff through infiltration into subsoil. 2, treating stormwater runoff through filtration by vegetation or soil. Or 3, storing stormwater runoff for reuse. So the fact sheet was created to help the public better understand that GI is very important for managing stormwater in that these BMPs more effectively maintain or mimic natural hydrology and provide environmental benefits by infiltrating precipitation to replenish groundwater and stream base flow, evapotranspiring or evaporating precipitation to reduce stormwater discharge volume, and by otherwise intercepting precipitation to reduce runoff and erosion. So there are also some co-benefits to using GI, and they include a reduction in urban heat island effect. You can see decreased energy use, removal of pollutants from the air through greater utilization of vegetation, also beautification of public spaces, and even increased property values. So where do we find the GI fact sheet? This is a snip from the bottom of our BMP manual webpage. After navigating to our BMP manual webpage at the link noted here at the top of the slide, and that was last updated in March of this year, the fact sheet for meeting the green infrastructure requirements is found on the lower right corner of the webpage after Appendix D, and it will download as a PDF file. Or as an alternative, the link at the top of the slide will take you directly to the PDF document. The fact sheet is an 8-page document that presents and provides some context to the information in NJAC 7:8, the Stormwater Management Rules. And just for simplicity, we'll refer to the Stormwater Management Rules just as the rules through the rest of this presentation, since we kind of say it a bunch. This is a snip of a portion of page 1 of the fact sheet. And next we'll take a look at what is in the fact sheet. But first, let's see what the rules say about GI. So here is 7:8-5.2a in the rules. And here is where you will find that the design and performance standards for groundwater recharge, water quality, and quantity control must be met using green infrastructure. Under item F in this subchapter, which isn't shown on the screen, is where you will find tables 1, 2, and 3, which list out BMPs and whether or not they are considered GI. BMPs listed under Table 1 are identified as GI. Table 2 is GI, requiring a waiver or variance if used for other than quantity control. And then Table 3 are non-GI BMPs. But this is just a review of what was covered back in Module 1 in the overview presentation. The tables also have important notes and footnotes that should not be overlooked. And if you need help understanding them, please feel free to contact us. So the takeaway from this is that the rules require a project to meet the design and performance standards using GI. And that means usually Table 1 BMPs will be used as they satisfy all of the requirements. But Table 2 BMPs, as covered earlier, can be used to address stormwater runoff quantity control. And when used for the other design and performance standards, Table 2 BMPs require a waiver or variance. Table 3 BMPs are not considered GI, and therefore will require a waiver or variance to meet any of the design and performance standards. Okay, so what is meant by a contributory drainage area? So subchapter 5.3 is where the rules identify which of the GI BMPs have fixed contributory drainage area limits, and a contributory drainage area is defined in the rules as the area that drains to a stormwater management measure, excluding the area of the measure itself. So on the fact sheet below the first paragraph on page 1, these limits are restated. Take note that the GI BMPs found in Chapter 9 of the BMP manual are not listed here. That are not listed here have one or more design components that limit the size of the contributory drainage area. That's, for example, say grass swales have size constraints and a maximum depth of flow limitation of 2 inches. And this design criteria will impact how much area can drain to a given grass swale. So next is how to implement GI into a project or make sure it has been properly implemented. The fact sheet includes a metric to help anyone evaluate if GI has been properly implemented. With any design, the 3 questions shown here must all be answered with a yes for the project to meet the GI rule requirement. So that is, stormwater must be managed close to its source. The BMPs used must be distributed throughout the site, and any BMP drainage area limitation must be met, and the reviewer will confirm that the answers to all 3 of these questions are correct. So let's go through these questions individually. So the first one, GI manages stormwater close to its source. So let's clarify what we mean by that. GI mimics the natural hydrologic cycle, and although stormwater traveling from this point here on the right is a lot farther or has a lot further to go than a drop falling here has to go to get to the basin over on the left side of the site. But remember that clearing, grading, and paving results in much shorter values that are calculated for runoff travel times because pavement is much smoother than natural terrain. Plus, we typically use uniform and flatter slopes for parking lots. So in conclusion, the basin is not close enough to the runoff generated by the far right of the proposed parking lot shown in this image. Also, there is little opportunity for stormwater to interact with vegetation or soil with this particular layout. So this layout is not considered as meeting the GI requirement. So this is an example of placing BMPs close to the source of runoff. And here's the project description. So we have a fully impervious 3-acre site in an urban redevelopment area, and it's proposed to be redeveloped again. The redevelopment will consist of a 1-acre building plus 40,000 square feet of parking area and internal driveways, and also a 1-acre overflow parking area. A green roof and an underground cistern are proposed to manage the rooftop runoff from the 1-acre building. Stormwater islands designed to infiltrate into the subsoil are proposed to manage runoff from some of the parking areas and internal driveways. And a permeable asphalt system designed to infiltrate into the subsoil is proposed to manage runoff from the overflow parking area. So the proposed redevelopment is a major development since it will disturb 1 or more acres and is therefore subject to the design and performance standards in the rules. However, because it is an urban redevelopment area and was previously fully impervious, groundwater recharge is not needed in this case. Additionally, the proposed condition reduces the impervious surface present on site in the existing condition, so there is no recharge deficit. So this is a plan view of the site that was shown on the previous slide. Since the existing site is so highly impervious, many of the non-structural stormwater management strategies required by the local municipal stormwater management plan could not easily be implemented on site. However, due to the proposed GI practices, the project breaks up or disconnects the flow of runoff over impervious surfaces and provides low maintenance landscaping that encourages retention and planting of native vegetation that minimizes the use of lawns, fertilizers, and pesticides. So in this example, all stormwater runoff generated by the redevelopment is managed close to its source. So we can answer with a yes to that first question on the GI fact sheet. So the next question to be asked is if the GI BMPs are dispersed throughout the site. So the previous site was certainly a good example of spreading BMPs throughout the site, and this is another one. The parking stalls shown here are actually pervious pavement, and they are separated by traditional impervious pavement aisles graded to direct runoff to the pervious areas. Roof runoff also drains to the subsurface storage beds below the pervious pavement parking stalls at either end without exceeding the drainage area limits. And so we can answer yes for this site as well. So now for a third site, the requirement to distribute GI throughout the site does not mean that multiple GI BMPs cannot be near one another. It's important they be close to the source of runoff, like these dry wells are to the building for which they manage runoff. So they are considered distributed because they are on 3 sides of the building. If this is part of a larger site where there are additional GI BMPs, this layout is fine. And a separate discharge for each of the 7 dry wells is not necessary as long as no more than 1 acre of runoff is directed to any individual dry well, which is the dry well's drainage area limitation. And to be GI, they must each function individually for the water quality and recharge storm events. So as long as those conditions are met, then we can say yes to the answer to the second question for this site as well. So another example, this is the small scale GI BMPs here are separated by berms and have contributory drainage areas below the maximum. However, all of the BMPs are concentrated in one area of the site. So for instance, look how far the building is from this cluster. So notice that how there are no stormwater BMPs on the right side of the parking area. Therefore, most of the BMPs shown here are not considered to be near the source of runoff they are treating. And the BMPs are not distributed throughout the site. So in conclusion, the design does not meet the definition of GI and thus does not meet the rule requirements. Okay, and the last question to be asked is whether the contributory drainage area of the proposed GI BMP is less than or equal to the limitation found in the rules at 7:8-5.3. Small scale bioretention basins are ideal for use in parking lot islands and where grass strips at the edges of parking areas or roadways were typically used in the past. The drainage area limit for a small scale bioretention basin is 2.5 acres, which generally is more than enough. All right, so with that, that's actually going to conclude our GI fact sheet portion of the presentation. And next, we're going to be reviewing a plan review example that focuses on using green infrastructure. So the goal of this part of the presentation are listed here. However, we will focus on green infrastructure. So for this example, we'll look at what was proposed and identify if and where the design falls short. So all reviews require figuring out which standards apply and then checking them for compliance. Questions we must ask and answer are, what is the disturbance on site? Does it trigger major development? Will the project be required to do water quantity, groundwater recharge, water quality? And are there infiltrating BMPs being proposed, which would require groundwater mounding? We will need to figure out all of that to see if they will apply in this review and how they will be addressed using green infrastructure. So it's important to know what the site looks like and what the pre-construction conditions are and what the existing land cover is. Plus, we need to take a look at soil testing information. So let's take a look at what's going on in our example. The property in question is a farm that had been such for a number of decades. The site's over 18 acres. The road running east to west at the front of the property is a county route with sizable traffic volumes. The property is adjacent to some forested properties along the back lot line, which is also a stream corridor. And the property drains towards the stream, which flows to the south before crossing under a roadway east of the property via a culvert. So here's the topographic view with the wetlands delineation and the 150-foot wetlands riparian buffers shown as the dashed lines. So this site is all sloped towards the stream. So the proposed development includes the clearing and grading of the property, construction of 25 single-family homes, widening of the existing road found on the right side of the plan and adding another internal road. Both roadways will be constructed with 6-inch curbs and will each end in a cul-de-sac. The stormwater management report indicated 4.7 acres of the impervious cover is proposed, without a breakdown though of into which is motor vehicle surface and which is rooftop surface. And that breakdown is important with the current rule. So we can start by checking the coverages. Each of the homes are about 0.35 acres on average, which is going to total to 8.75 acres in total. The proposed roadways are 28 feet in width, ending in a 50-foot radius cul-de-sac. So that ends up being roughly 70,000 square feet or 1.6 acres of new motor vehicle surface proposed. Additionally, the existing portion of the roadway along the east side of the property will be newly collected where no collection system existed before. So it also counts towards that net increase in motor vehicle surface. So we can safely say that these totals exceed the threshold for major development. And so this is a major development. For this project, compliance must be demonstrated with the GI requirement, the water quality, stormwater runoff quantity control, groundwater recharge requirements as well. And if infiltration is proposed, groundwater mounding, plus safety and maintenance requirements in the rule. So to address water quality and the green infrastructure requirement, 4 small-scale bioretention basins with under drains are proposed. And here's where they would be located. So first, let's look at the soil exploration map, which indicates that a number of test pits were completed. Although at the time this plan was prepared, only one central stormwater management basin was anticipated, as shown in the center of the site. And that's probably due to the preliminary concept predating the current stormwater management rules. As we know, major development projects are required to use green infrastructure best management practices, which are smaller in scale and treat stormwater runoff close to the source. So it's good that the designers realized the single basin approach wasn't compliant and went with multiple BMPs. The reviewer would also want to check that for the revised design, the proper number of test pits and soil borings were performed. In this case, the soil testing report was not revised to meet the testing location requirements for the updated basin layout. From the test pit findings, the seasonal high water table was determined to be at depths between 3 and 6 feet, mainly because modeling was observed, and the boxes shown here show these depths below the existing grade. Where this depth is preceded by an asterisk, and this is for the values at the bottom right corner of the site, it's an indication that cemented soils were observed. Additionally, from the test pits 10, 11, and 12, the tested permeability rates were far below the minimum allowed rate of 1 inch per hour, meaning that GI BMPs designed to infiltrate could not be used in that area. And lastly, here are the approximate locations of the 4 proposed BMPs so that you can see which test pit most closely corresponds to which proposed basin. So let's look at the drainage area map for the proposed condition next. So here is the drainage area map. The different color areas represent the different drainage areas, and you can see which areas are contributory to which BMP. Each of the BMPs are under drained small scale bioretention basins, and although it's difficult to see without zooming in here, but each contributory drainage area is less than the allowed maximum 2.5 acres, and that's specified in 7:8-5.3b of the rules. So that's going to appear to meet one of the requirements for green infrastructure, which was that third question we asked earlier in the presentation. However, if we look at the layout of the basins, the placement of some of these basins are too far from the source of runoff, mainly the basin towards the the basins towards the bottom right of the site. So basin number 2, which is shown here in blue, is not close to the source of the runoff, which, as previously stated, is a requirement for green infrastructure. Its contributory drainage area is not near the center of the property where the basin is located. Basin number 3, which is shown in red, is located too close to basin number 2. They're only separated by a berm. And the basin, despite being located in the southern half of the property, is collecting runoff from all the way in the northeast corner of the site. And something similar can be said for basin 4, which is shown in yellow. It's the southernmost located BMP on site, and although it may be difficult to see again on this image, but it's also collecting runoff from the northeast corner of the site. So there is some engineering judgment involved in this, of course, and it depends on the circumstances each particular site may be subject to. But for this site, even though each of the drainage areas are below the contributory limit, most of the BMPs proposed as being GI BMPs are not located as close to the source of runoff as they could be, nor are they distributed throughout the site as they could be. So this layout would not meet the GI requirements. By grading these post-constructed drainage areas slightly differently than what's shown here, and modifying the location of these basins to be closer to their contributory runoff source, and would help to spread the basins out into a more balanced distribution throughout the site. And lastly, just wanted to note the green drainage area here in the center of the site has roof area generated runoff that is not detained, and that actually may be an issue when we address how the site complies with the quantity control standard. Okay, so now that we've determined that the design does not meet the GI requirement, we can cover the other instances where the project does not comply with the rules. So here's a basin section detail. The details for each of the BMPs otherwise show most of the requirements for online bioretention systems with under drains, which is good. However, the report did not mention that did not mention what the bioretention growing media specification is. So that would be something to add to the review letter. Also, a maintenance plan was not included with the report. So without those two items, the BMPs do not merit their TSS removal rating, meaning that they do not meet the stormwater runoff quality standard. And this will also go into the review letter. Next point, the stormwater calculations that were prepared in 2022 and used the type 3 stormwater distribution for the 210 and 100-year design storms. And as per the 2021 publication in Chapter 5, the NOAA C or D distribution should have been used. So that will also go into the review letter, and new calculations would be required. So this site, as is, would not meet the runoff quantity control standard until that correction is made. For groundwater recharge, the report states that the project demonstrates compliance with subsection 5.4 of the rules because all of the runoff is collected and infiltrated. That statement is false with respect to the current design. It may have been true for an earlier iteration of the design, but as we saw, they are proposing under drain bioretention basins, which of course will not provide groundwater recharge. And in line with this idea that the proposed BMPs are providing recharge, the narrative of the stormwater report also states that the proposed 2-year hydrograph volume is less than the existing 2-year volume, as shown from this excerpt here. However, this narrative is incorrect and actually conflicts with the report calculations, which show an increase in volume of runoff by the proposed design. So the project will have to be revised along with the narrative, and also no further detail is provided in the report on meeting the groundwater recharge requirement. And another thing to add to the review letter is a reminder that if the design were actually infiltrating runoff into the underlying soils, then a groundwater mounding analysis would also have to be included. Okay, so in summary, this presentation covered what is meant by green infrastructure, or GI, which I'll state again here, is a stormwater management measure that manages stormwater close to its source by either treating stormwater runoff through infiltration into subsoil, treating stormwater runoff through filtration by vegetation or soil, or storing stormwater for reuse. The fact sheet was created to help the public to better understand GI and how to implement it, along with examples of situations that are considered as not meeting the definition of green infrastructure. To address water quality, groundwater recharge, and runoff quantity control, the rules require GI to be correctly used. And answering the 3 GI questions shown here when you review a design will assist in determining if GI is properly implemented on a site, meaning the GI BMPs are located close to the source of runoff, they are distributed throughout the site, and that the drainage area limitations are met. So that concludes my presentation. Hopefully you found it a little helpful. Thank you for your attention. Here's my contact information. With that, I think we're going to move on to another review example, which is presented by Minesh. Thank you.
All right, thanks, Anthony. Let's go through our plan review example number 2 before we get to our quiz to end the day. So the goals of this presentation are the same as those for the prior example. We will focus on whether the project meets the requirements for green infrastructure, and we'll look at what was proposed and identify where the design falls short. So let's take a look at what's going on in our example. We'll start with what the site looks like, what the pre-construction conditions are, and what the existing land cover is. So the property in question is a site covering roughly 11.7 acres that is primarily undeveloped and wooded. It contains the abandoned ruins of a single-family residence and related outbuildings on the northwest portion of the site. The site runs alongside a state highway, and to the west of the property is a conservation easement containing a ponded area draining to a tributary of a local river. The site itself receives stormwater runoff draining from the east side of the divided highway, and there are some mapped wetland areas on the site. So let's take a look at the drainage area map for the existing conditions. So here's a topographic view. As you can see, the arrows here, they depict how the site would flow. Some flow from the road to the northwest, and some flow from the highway to the east. Everything is going to be flowing towards the southwest portion of the site, with the high point being in the northern area. The proposed development, it includes the clearing and grading of the property. There will be a construction of 152 age-restricted affordable housing units in a single multi-story building, a single access driveway, a surface level parking, and multiple stormwater basins that will discharge to the southwest corner of the property to support the existing drainage patterns. The project will be constructed in 2 phases. The first will include 84 units, and the second will be 68 units, which are located on the left side of the building as shown. From the stormwater management report, the narrative states there are 3 small-scale infiltration basins along the southern border that are designed to provide extended detention of the larger design storms. Plus a northeast detention basin for the off-site runoff entering the site to the north and the east. So immediately, there is a big issue with this design. All 3 of the basins that are proposed to meet the GI requirement, they're grouped at the southern side of the project. So clustering these BMPs together is not compliant with the GI requirements. Remember, the BMPs have to be distributed throughout the site and manage stormwater close to its source. The proposed design is going to rely upon infiltration of runoff to meet the groundwater recharge requirement and water quality. So let's look at the web soil survey results, followed by the soil testing data before we evaluate the overall design further. So as you see here from the soil survey, the site is mapped as HSGA, which is pretty promising for infiltration. So let's look at the soil testing findings. So 2 sets of soil investigations were conducted. A total of 20 test pits were performed. The first group, shown in green, are from April 2021. And the second group, shown in blue, are from January 2022. I've superimposed the 3 proposed small-scale infiltration basins onto the soil testing map just to show which test pits correspond to the respective basins. Your review would also include a check of whether a sufficient number of test pits and soil borings were performed, along with the depth of the investigation, which I'm not going to cover here because we're going to focus on just the GI aspect. I've also added the depth at which the logs show the soil permeability was determined, taking note that groundwater was not encountered at any of these locations. The brown shaded rectangles denote results for other test pits. And for test pits number 3 and number 5, groundwater was encountered at 5.5 feet below existing grade. For test pit number 6, groundwater was found at 6 feet below grade. And lastly, a perished water table was found for test pit number 8 at 10 feet below grade. As with the blue shaded test pits, groundwater was not encountered at the ones I did not call out. But the report shows quite a variation in the test results for permeability. So let's look at the table of the testing results. So here's that table, and I've circled the locations where the field tested permeabilities were less than an inch per hour. Unless soil replacement is proposed, these locations really aren't suitable for infiltration BMPs. Given the low permeabilities at the encircled test pits, we will have a problem with the ability of the orange and yellow shaded basins to drain properly. We'll add this to the review letter. Next, let's look at information found in the stormwater report, which states the 3 basins are designed as small-scale infiltration basins, but we do have to check if they really are. So here is the node diagram from the stormwater management report. These are usually upfront in the materials submitted, and I use them to look at how the site is modeled and make any notations as I start my review. Basins 27P, 24P, and 38P, they are the basins that are numbered 1, 2, and 3, respectively. And they have superimposed the inflow areas taken from the basin summary reports with the totals appearing in the brown shaded boxes. The node report, it shows basin 1 that drains to basin 2, and that will then drain to basin 3, such that the contributory drainage areas appear to exceed the 2.5 acre limitation that's established in the rules and in the GI fact sheet. The connections between BMPs is something that has to be checked to determine if this is true. Remember from the fact sheet presentation that the GI BMPs have to function individually for the water quality and groundwater recharge design storms, and each has to meet the contributory drainage area limitation. Perhaps the drainage area map can provide clarification, and after that, we'll look at the construction details to see how this design will actually function. So here is the drainage area map for the post-construction condition. This shows the contributory drainage to each small-scale bioretention basin is less than the allowable maximum of 2.5 acres, which appears to demonstrate compliance with NJAC 7:8-5.3. But we have to dig further to evaluate how individually versus connected the basins perform when it comes to the water quality, the 2, 10, and 100-year design storms. But before we dive into the construction details, I just want to say that I'm not including further review information for the quantity control and groundwater recharge. For the required groundwater mounding analysis for infiltration BMPs, the only analysis was for Basin 1, and the most restrictive hydraulic conductivity with the factor of safety was not used in the calculation. So this should also be in your review letter. So here's a close-up image taken from the plans, and I've added construction details that shed light on how these basins actually function. So basin 1 is on the right, and A-9 is the outlet control structure for it. The top grate is the sole means by which runoff discharges from the basin. Since the grate is at elevation 63, the water quality design storm will infiltrate, and the 210 and 100-year storms overtop the grate will flow to basin 2. And that will have the outlet structure B11. And if you look at this detail, the lowest orifice has an invert of 50, which is below the water surface elevation of the water quality design storm that's contributory to basin 2. So basin 2 wouldn't meet the design criteria for infiltration basins according to our BMP manual. And similarly, the lowest orifice at OSC-10 is below the water surface elevation of the water quality design storm. In conclusion, basins 2 and 3 do not meet the design criteria for infiltration basins according to the BMP manual, and would not merit the 80% TSS removal rating. These contributory drainage areas would most likely be larger than the ones that you would find in Table 5-1. They'd probably be more suited for those in Table 5-2, which would require a variance before they can be used for quality and recharge. Waivers are for the enlargement of an existing public roadway or railroad, or the construction or expansion of a public pedestrian access, which this project was not. The next slide will revisit the subject of variances. There are strict standards to be met in order to grant a variance. More specifically, the municipality has to have a mitigation plan in place that identifies what measures are necessary, potential mitigation projects, and/or criteria to evaluate mitigation projects that can be used to offset the deficit that's created by granting a variance. Additionally, the conditions shown here in part from the rules must be met. The applicant has to demonstrate it is technically impracticable to meet one or more of the design and performance standards that are on site. And like we've been talking about in the modules prior, these reasons can only be engineering, environmental, or safety based. Furthermore, the variance cannot be for the entire site unless an analysis is provided for each drainage area within a site. The applicant also has to demonstrate maximum possible compliance is provided by the design. So don't forget, there is also a reporting requirement for variances. What's not shown in this excerpt is item 3, which is about the mitigation plan, which has to be within the same HUC 14 and approved no later than the preliminary or final site plan of the project. Moreover, if the variance is for green infrastructure, then the mitigation plan must use GI BMPs to manage an equivalent or greater area of motor vehicle surface. There are 7 other parts to the mitigation plan from this section of the rules that I'm covered here. But in short, a municipality cannot grant a variance now like it may have done in the past. Since information was also not provided on mitigation projects here, the project is not compliant with our rules. So let's conclude the review of this example by answering the 3 GI questions for the proposed design. Even though only one small-scale infiltration basin was actually proposed, they must all be answered with a yes for the project to meet the GI rule requirement. So the first one is the BMPs were not located next to the parking areas, so the first answer is no. Question number 2, the BMPs were all located near each other along the southern property line. So the answer to are the BMPs distributed throughout the site? That answer is going to be no. And question 3, are the drainage area limitations met? It didn't look like basins 2 and 3 infiltrated the water quality design storm and were instead discharging downstream during the water quality design storm. So the answer is likely no here. So to wrap things up, this project does not comply with the requirements to use green infrastructure to meet the design and performance standards for water quality, groundwater recharge, and stormwater runoff quantity control. So that about does it here for example 2. Thank you for your attention. Before we move on, Changi, are there any further questions, comments that need to be addressed?
I will address all those questions in chat, so please move on for next presentation. Thank you.
All right. So it is quiz time. I will hand over control to Peter, who will guide you through quiz number 4. Thank you.
All right, thanks, Manesh. I will share my screen now. All right, so it is time for quiz number 4. But before we start the quiz, we would like to remind you of a few important things. Upon conclusion of the course, we'll send out via email a course evaluation survey within the next couple weeks. The survey must be completed to receive either a certificate of course completion or a certificate issuing CPC credits. So if you review for an MS4 permittee, attended all 4 modules, complete all 4 quizzes, and are required by permit to complete this training every 5 years, you'll have to complete the survey before we send out the certificate of course completion. Likewise, if you are a professionally licensed engineer and you wish to receive a certificate issuing CPC credits, completion of the survey is prerequisite to us issuing any credits. Also, just to note that the slides and recordings for this training will be made available on the training webpage at the link here, and they'll be updated for future sessions of this course, which we typically try to host twice a year. As with the other quizzes, you may access the quiz in a few different ways. The link in the middle of the slide will take you to our training webpage, which has the link for quiz 4 along with the other quizzes and handouts. You may also use the direct SurveyMonkey link, which is shown here and found in the chat. And make sure that the quiz is opened in a separate tab on your computer if you do open it on your computer. And lastly, you may use the QR code, which is found in the chat, and take the quiz on your phone. Now, when you start the quiz, you'll notice some of the quiz questions will be new, and some will actually be repeats from previous quizzes. These are the questions that had the lowest correct answer percentage. So this is sort of a recap. As usual, we will review the quiz after everyone is finished. Please make sure to click submit at the end of the quiz to get credit for completing it. All right, so it's about 2:57 right now, so we're going to give 10 minutes for the quiz. So let's all meet back here at 3:08 for the review. So here's the link and QR code again. You may begin the quiz and we'll meet back up at 3:08. Thank you. Hi, everyone. We see that some of you are still working on finishing the quiz, so we're going to give you a couple more minutes to work on the quiz before we start the review. All right, hello everybody. Looks like pretty much most of the class is finished with the quiz. If you are finishing up the last few questions, you can feel free to while I begin the quiz 4 review. All right, here we go. Number 4, true or false? Green infrastructure, or GI, is defined in NJC 7:8 as a stormwater management measure that manages stormwater close to its source by 1, treating stormwater runoff through infiltration into subsoil, 2, treating stormwater runoff through filtration by vegetation or soil, or 3, storing stormwater runoff for reuse. And this statement is true. The definition quoted here matches up with what is found in the rules. Number 5. Which questions need to be answered yes when designing a major development to meet the GI requirements? And D, all of the above, is the right answer. So, as found in the GI fact sheet, the stormwater must be managed close to the source, the BMPs must be distributed throughout the site, and the drainage area limitations, as applicable, must be met when designing a major development to meet the GI standards. Number 6. Which of the following GI BMPs has a contributory drainage area limit, that is other than 2.5 acres? And the correct answer is dry wells. Dry wells have a 1 acre contributory drainage area limit per 7:8 5.3b. This information was also in the slides from the GI fact sheet presentation. Number 7. Unless a variance is granted, which of the following BMPs cannot be used to meet the quantity control requirement? And the answer is extended detention basins from chapter 11.2 of the BMP manual. In accordance with NJAC 7:8 5.2, extended detention basins cannot be used unless a variance is granted. The presentation for example 3, specifically slide 12, included the information on what must be in place for a municipality to grant a variance from the GI requirements. Question 8. Yes or no? Can GI BMPs be located near one another for the following scenario? There are 7 dry wells located adjacently on 3 sides of a large building. No more than 1 acre of roof runoff is directed to each individual dry well, and each dry well will function individually for the water quality and recharge storms. And the answer to that is yes. This material is covered on slide 13 of the GI fact sheet presentation from earlier today, and you can find more information about this setup on the GI fact sheet itself. The important factor here is making sure the answers to the 3 questions for GI are yes. Number 9, which of the following is recognized as a co-benefit of using green infrastructure? And the correct answer is D, all of the above. As described on pages 1 and 2 of the green infrastructure fact sheet, all 3 of these are environmental, social, and economic co-benefits of using green infrastructure. Additional co-benefits include increased property values and the removal of pollutants from the air through greater utilization of vegetation. Number 10, yes or no? Is the interconnection between GIBMPs and the following scenario acceptable? A small-scale bioretention system infiltrates runoff for the water quality and groundwater recharge storm events, meeting the 2.5-acre contributory drainage area limitation. The 2, 10, and 100-year storm events are discharged from the small-scale bioretention system to a large-scale infiltration basin, which is used only for water quantity. And the answer to that is yes. From NJAC 7:8 5.2, the downstream large-scale infiltration basin can only be used to meet the quantity control requirement and is not subject to the contributory drainage area limitations found in 7:8 5.3b. Additionally, the upstream small-scale bioretention system fully infiltrates the water quality design storm and the recharge storm. Number 11. Which of these can be used to demonstrate compliance with the water quantity, design, and performance standard? And B is the correct answer. Design stormwater management measures so that the post-construction peak runoff rates for the current and projected 2, 10, and 100-year storm events are 50, 75, and 80% respectively of the pre-construction peak runoff rates. Number 12, true or false? A project located in a tidal flood hazard area is always exempt from the water quantity standard. And this statement is false. In tidal flood hazard areas, the water quantity standard does not apply only if the applicant can demonstrate that the increased volume of stormwater runoff will not increase flood damage below the point of discharge. In tidal flood hazard areas, stormwater runoff quantity analysis is required unless the design engineer demonstrates through hydrologic and hydraulic analysis that the increased volume, change in timing, or increased rate of stormwater runoff, or any combination of the three, will not result in additional flood damage below the point of discharge of the major development. Also, no analysis is required if the stormwater is discharged directly into any ocean, bay, inlet, or the reach of any watercourse between its confluence with an ocean, bay, or inlet, and downstream of the first water control structure. Number 13, yes or no? Can the Delmarva dimensionless unit hydrograph for the redevelopment of a 2-acre entirely impervious site located within the coastal plain? And the answer is no. The Delmarva dimensionless unit hydrograph must be used when modeling watersheds within the coastal plain region of New Jersey, with just a few exceptions. It cannot be used to size a manufactured treatment device or MTD, as it may underestimate the peak flow rate entering the MTD. Also, for an entirely paved site, the significant surface storage associated with the coastal plain is no longer present, also resulting in underestimated peak flow rates if the Delmarva is used. Additionally, the Delmarva should only be used in areas that have an average watershed slope less than 5%. If any of these situations are proven to be present, the SCS standard dimensionless unit hydrograph must be used. And a side note on this subject, if the Delmarva is used in the pre-construction condition, it must also be used in the post-construction condition. Same idea goes for the SCS. Number 14, soil testing logs prepared in accordance with Chapter 12 are required for which of the following BMPs? Correct answer is all of the above. They all have a minimum separation from the seasonal high water table, which you can find in their respective BMP manual chapter. Soil testing would therefore be required for all of these to ensure that they meet the required separation. Number 15, which of the following would be exempt from the groundwater recharge standard? And the correct answer is B, previously developed portions of a site in a designated area. Just being in planning area 1 is not an allowed exemption from the groundwater recharge standard, nor is redevelopment automatically exempt. Only previously developed portions of sites in the designated locations listed on the slide can be exempted. Number 16, which of the following conditions must be met when a stormwater BMP is allowed to infiltrate the entire runoff from the 2, 10, or 100-year storm? The correct answer is all of the above. Infiltration of the entire 2, 10, or 100-year storm is only allowed when existing site conditions are such that no runoff leaves the site for the pre-construction condition scenario, thereby constraining the design to infiltrate 100% of the volume produced by the post-construction condition for the same design storm. The maximum storm that can be entirely infiltrated is the largest storm event with no runoff leaving the site in the pre-construction condition. For example, if there's no runoff for the pre-construction 10-year storm, but there is for the 100-year storm, then for the proposed condition, the maximum design storm that can be fully infiltrated is the 10-year storm. And the answers for B and C paraphrase what is found in the rules. Only small-scale GIBMPs can be used to infiltrate runoff of a storm larger than the water quality design storm, unless required by another rule or agency. And soil testing of saturated hydraulic conductivity must be performed strictly following Chapter 12 of the BMP Manual. Number 17, under the rules adopted July 17, 2023, which of the following meets the groundwater recharge requirements? And A and C are the correct answers. The rules adopted on July 17, 2023 allow two options to meet this requirement. One is maintaining 100% of the average annual pre-construction groundwater recharge volume for the site. That option of meeting the requirement hasn't changed under the amended rules. The second option is to infiltrate the increase of stormwater runoff from pre-construction to post-construction for the climate change projected 2-year storm. So the change under the newly adopted rules is that the storm event used under this option is the projected 2-year storm. Number 18, true or false? Under the rules adopted July 17, 2023, the storm events used to meet the stormwater quantity standards shall consist of the current and projected 2, 10, and 100-year storm events, as defined and determined pursuant to NJAC 7:8, 5.7, C and D, respectively. And this statement is true. Under the rules adopted July 17, 2023, both the current and projected design storm events are required to be used in the design of stormwater management BMPs to meet the stormwater runoff quantity control requirement. Question 19, true or false? Under the amended rules, a manufactured treatment device can be sized by using the rational method. And the answer to this one is false. Under the amended rules, use of the NRCS methodology for stormwater runoff calculations is now required. All right, so that concludes the review for quiz 4. Up next will be Gabby with an MS4 program overview and some closing comments. So just please stand by as I hand over control to Gabby.
Okay, let me share my screen. The computer is giving me an issue. Give me 1 second. Thank you for those, for helping. Sorry for those technical difficulties. My name is Gabrielle Spinelli. I'm an environmental specialist in the Bureau of Gypsy Stormwater and Water Quality Management Bureau. So I'm just going to give you a wrap up of some MS4 program overview and some closing comments. So the department currently has 3 authorized permits. We have the Tier A permit, which has 557 municipal permittees authorized under the Tier A permit. There are a few municipalities that are not regulated under this permit because they do not have an MS4 system. They either have a fully CSO town or they are just not publicly owned. And the Tier A permit was last renewed in January of 2023. As part of the renewal process, the department addressed EPA's concerns to reevaluate the Tier A and Tier B designation to determine if any of the town's MS4 systems need to be authorized under the Tier A permit. We found that all Tier B towns required reassignment due to the population density increase in urban areas or due to discharges to impaired waters and/or waters with TMDLs. And this permit will expire in 2027. Other MS4 permits include the public complex permit and the highway agency permit. We currently regulate 71 public complex facilities, which include public colleges, universities, hospitals, and/or prisons. The public complex renewal was finalized by January 2024, and with that, there were 13 new public complexes that were added into this permit due to the reassignment from the Tier Bs. There are 33 highway agencies regulated under the highway agency permit, including state and county DOT roads. This includes agencies like the Turnpike, Bridge Commissions, and the Parkway. This permit is currently being renewed and is due to expire at the end of this year. So it is currently being drafted and is anticipated to be finalized by January of 2025. MS4 permits have a number of requirements, including these key requirements noted here. We will be going into more detail regarding these requirements later in this presentation. In the meantime, please take a look at this list. Just to note, we have only listed some of the requirements on this slide. I'll discuss the enhancements to the public complex renewal that became effective January 1st, 2024 shortly, which are similar to those that were also changed in the Tier A 2023 renewal. This is a list of the notable changes in the public complex permit renewal. I'll give you a moment to read this list, and I will go on some of these changes more in detail. These are extremely similar to the enhancements made to the Tier A permit in 2023. Please note that the permit includes other changes. There are some new BMPs for maintenance yards, excess salt and de-icing materials that have been deposited during spreading operations on all complex-owned roads and parking areas must be removed within 72 hours after the end of a storm event. We are asking for a dedicated stormwater page for employee training and for this the SPP to be modified once a year. Many of these enhancements have been made to address water quality problems such as impairments and TMDLs that affect our waters throughout the state. So with the post-construction stormwater management and new development and redevelopment, there are 2 major changes to this condition. First, we clarified the permit language to say that design engineers cannot approve their own designs. Next, for any amendments to the stormwater management rule, training sessions will be necessary for stormwater design reviewers. This is because attendance at the training, the one we're at right now, is only required once every 5 years, and we don't want to wait that long to train people on these amendments. Rule amendment training sessions pursuant to the rule adopted in July of this year have been announced to the department's website and will be emailed to all stormwater program coordinators and people who have attended swim dare courses. This training requirement will also apply to any future rule amendments. Attendance is and will be mandatory and must be completed within 1 year of the adoption of the amendments to the NJAC 7:8 rules. There has been no change to labeling inlets. The change here is that all remaining storm drain inlets that have not yet been retrofitted due to utility work or paving projects must be retrofitted by the end of this permit cycle, and that is for the public complex, by December 31st, 2028. The entire structure can be replaced with an updated one, or you may attach a bolt-on plate to reduce the size of the vertical opening of the old inlet. In addition, all newly installed inlets must have a catch basin or other BMPs to collect solids. We've also included an exemption for catch basins on bridges. So for the roadside erosion control program, this is a condition that was in the 2024 Tier A permit that was removed in the 2009 permit renewal, and this was also the case for the public complex. The reason is that at the time, it was reviewed as a redundancy since municipalities are required to control erosion under the standards for soil erosion and sediment control in New Jersey. However, those standards only apply to construction sites, not necessarily to existing roadways, and we have received complaints about ongoing roadside erosions in various towns. The photo shown on this slide was taken by one of our enforcement officers, who was also investigating an erosion complaint. So we have reintroduced this condition in the renewal. Erosion checks can be done while performing other stormwater inspections, so you don't need to schedule additional trips. If problems are identified, we allow 3 months to address it unless another time frame is authorized by the department. We want to clarify and point out that inlet inspections and catch basin inspections are different activities and have different schedules. The condition of storm drain inlets can be observed with a simple drive-by type of inspection and a quick sweep or shovel if the grate is clogged. For this reason, we require that all storm drain inlets are inspected every year. Catch basins, on the other hand, require additional work. The inspector must go out of the truck to inspect the inside of the catch basin to determine if cleaning is needed. We ask that catch basins are inspected a minimum of 20% of the total every year on rotation, so that all catch basins are inspected by the end of the permit cycle. So for stormwater infrastructure inspections, we need some clarifications. The clarification is to highlight that the permittee is required to properly inspect, clean, operate, and maintain all stormwater management measures. This is a catch-all condition since it's referring to all remaining stormwater facilities not mentioned specifically in another permit condition, such as stormwater management basins and other MTDs. This program should define what conditions warrant cleaning, proper operation, and maintenance of any remaining stormwater infrastructure, and establish an inspection schedule that is tailored to your municipality's characterizations and resources. If there is not an approved maintenance plan, towns can prepare a retroactive maintenance plan for certain infrastructure or inspect at least 4 times annually and after each rainfall or 1 inch or more. Keep in mind that inspection logs must be maintained for these. The requirement for illicit discharge detection and elimination inspections has been modified so that all MS4 outfalls are inspected for illicit discharge at least once every 5 years. You must inspect 20% of the total annual on rotation so that all outfalls have been inspected by the end of the 5-year permit cycle. All new or identified outfalls, as well as complaints or reports of illicit discharge, must be inspected within 30 days, and any reports of illicit discharge need to be remediated within 12 months of discovery. These inspections can be done with stream scouring inspections. Originally, public complex permittees should have already mapped their stormwater outfall pipes and will now need to map the rest of their infrastructure. This means mapping everything that collects or conveys stormwater, including outfalls, groundwater discharge points, internet connections, storm drain inlets, manholes, stormwater conveyance systems, pump stations, and other stormwater facilities you may have. You are also required to map the boundaries of the maintenance yards and ancillary operations. These MS4 infrastructure maps must be submitted electronically, and this does not mean a PDF sent via email. Rather, it means submitting a georeferenced shapefile, geodatabases, or an AutoCAD files with other non-applicable data stripped out. The department has developed a free mapping tool for permittees to use, and we can additionally provide ArcGIS Online licenses for free. Additionally, the tool has been updated to accommodate for additional stormwater facilities and features that are required to be mapped. Lisa covered this. This was covered on the first day of training. If the New Jersey mapping tool is used, data submittal is automatic. Otherwise, the files will need to be uploaded via the online stormwater document submittal service. The MS4 infrastructure map shall also be posted on the permittee's dedicated stormwater webpage when it is complete. Here you can see a list of new or modified BMPs for maintenance yards and other ancillary operations. Note, these requirements that were previously included in the attachment E of the public complex permit are now actually in the body of the permit. Note, all BMP listed here have been modified from the 2019 permit with addition of a few new BMPs. As in the Tier A permit, the public complex permit will no longer authorize stormwater discharge from wood chipping or leaf composting activities, as these will need to be covered under the department's new wood waste recycling and leaf compost general permit. I will go over this permit in a couple slides. Some of these changes that have been made include scrap tires must be stored in a covered container or enclosure. Inoperable vehicles or equipment can be stored on site for up to 6 months and must be inspected monthly. All containers and dumpsters that are stored outside must be covered at all times to prevent exposure to stormwater. If outside, bulk liquid materials must be stored in secondary containment such as the spill containment dikes. Aggregated material and construction debris can be stored on site for up to 6 months, but no processing activities are authorized under this permit. Cold patch asphalt shall be stored in a permanent structure or covered with a waterproof material on an impervious surface. These are the MS4 training requirements. The SPC training requirement is required for all SPCs so that they know their responsibilities for implementing the stormwater program. This is required once per permit cycle. The employee training requirements, including implementing an employee training program to address permit components and stormwater pollution prevention plan requirements. The SWIMDR training requirement, which we're all here, is a stormwater management design review training, which we are going to complete in a couple minutes. The municipal board and governing body members training requirement is training for board and council members. This training is a higher level training intended to familiarize those members with the permit and permit requirements. This is required once per term. Public complexes and Tier A's are required to do a watershed improvement plan. There are many water quality impairments resulting in TMDLs that affect waters across our state. Some of these impairments affect fish and aquatic biota, drinking water intakes that supply the water we drink, and even in rivers and coast waters where many of us swim every summer. Harmful algal blooms in many lakes due to water quality impairments are also occurring more frequently in the summer months. Some of these waters have no other discharges into them other than the local MS4. Therefore, the department requires that each Tier A and public complex develop a watershed improvement plan to determine what improvements can be made to reduce their contribution of pollutants that are causing impairments to the state's waters. The watershed improvement plan is split into 3 phases with separate due dates. The watershed improvement plan shall be updated when necessary based on the biannual review of revisions to the impairments of the permittee's water bodies based on the department's integrated report and newly adopted TMDLs. And these 3 phases are here. I want to quickly mention the Stormwater Assistant Grant. While we have gotten most of the applications for this grant, there are a few people who are struggling. So we would like to take this time to mention, if you are one of those towns, please get your application into us. The department has former TRVs are eligible to get up to $75,000 in aid, and original tier A's are eligible to get up to $25,000 for the development of their MS4 infrastructure map. So this permit is only for tier A's. This is a reminder that these ordinances need to be completed. We have added 2 additional ordinances to this permit and are providing 2 model ordinances to aid municipalities in this adoption process. The first one is the private salt storage ordinance, requiring owners of private properties and businesses such as malls, shopping centers, and others to properly store salt and other solid de-icing materials. The next one is the tree removal / replacement ordinance to reduce runoff and to promote infiltration. Some towns may have similar tree ordinances, and if their existing tree ordinances meet the minimum permit requirements, the town does not need to adopt our model. Note that we have completed evaluating the comments submitted to the 2 drafts and have finalized both of these model ordinances on our website. And if you have questions about either of these ordinances, you may email your case manager and they will help review your tree ordinance and your salt storage ordinance if needed. And in March 2019, the Stormwater Utility Law, officially known as the Clean Stormwater and Flood Reduction Act, was signed into law. This act authorized local and county governments and certain other entities the ability to create stormwater utilities. These allow for fees to be collected to be used for stormwater-related activities. Depending on the unique circumstance in each community, the process to establish a stormwater utility may take up to 5 years or more. There is a lot of information on our website that outlines the steps for establishing a stormwater utility and has many resources on how to do a feasibility study and creating a fee structure. Please reach out to your case manager with any questions about stormwater utilities or if you have interest in creating one. Here is a list of general categories which the stormwater utilities fees can be used to be paid for. Please refer to the stormwater utility website for more specifics on each category. So I'm going to discuss the wood waste recycling complex, and I want to describe the background and reason why the creation of this permit. First and most importantly, wood waste recycling and leaf composting are federally regulated industry activities that will need an EGIPTI stormwater permit, whether it be the general permit or another stormwater permit. While federal regulations require facilities that process wood waste or compost yard trimmings to get authorized under an EGIPTI's permit, those facilities are not stuck with the WRC permit as their only option. Facilities may obtain authorization to discharge under an individual permit, a 5GT stormwater general permit, or obtain the WRC permit depending on the level of exposure to stormwater. If a facility does not wish to obtain a WRC permit, but the industrial activities occurring on site and the source material stored on site are exposed to stormwater, then an individual stormwater permit is required. RF permits typically have more stringent requirements, including additional BMPs and monitoring parameters. This permit was created to address current gaps in the permit coverage from the wood recycles general permit, individual permits, and the MS4 Tier A permit. The department's wood recycling general permit, also known as the R7, expired in 2014, and renewal was needed. This general permit allows the department to include multiple facility types and ensure the proper permit coverage is established for stormwater discharges from wood waste recycling activities statewide. Specific to municipal facilities, the 2018 Tier A permit only covered the temporary storage of wood waste and yard trimming materials and resulting stormwater discharge to groundwater, and it didn't authorize discharges to surface waters from any processing activities. Through MS4 compliance audits, we found that municipal facilities that perform these activities were not properly managing their stormwater discharge and therefore contributing pollutants to the surface of groundwater. Since some facilities are not permitted, they are currently discharging stormwaters from these activities with no BMP in place. We also found that many facilities operating without a stormwater permit, including those listed under a solid waste exemption. However, operating under a solid waste exemption does not exempt you from the requirements of the stormwater permits or other programs within the department. In recent years, there have been a more urgent need for stormwater management measures in order to alleviate water quality concerns statewide. These recycling activities can be contributors of significant amounts of nitrogen and phosphorus. By implementing BMPs at these sites throughout this new permit, we hope to alleviate some of these water quality concerns statewide. Some of the permit requirements for the WRC include the Stormwater Pollution Prevention Plan, and it needs to be submitted to the department within 3 months and then implemented within 12 months from receiving the permit. The SP will require a site-specific narrative description of the activities and the association locations occurring during the site, and an inventory of source material. It must also include BMPs to eliminate, reduce, or minimize exposure of industrial activity and source material from stormwater discharges to surface water or groundwater. BMPs also need to be in place for stabilizing surface soils and reduce sediment transportation. There must be also a drainage control plan, and a drainage control map must be included in the SPPP. The narrative portion of the drainage control plan shall include times of concentration calculations, sizing calculations for stormwater facilities, and applicable TMDLs and impairment information. The SPP shall be retained at this facility for use by the permittee and for inspection by the department. Additionally, the SPP shall be made available to the public upon request. We also want to note that this list is not inclusive of the SPP requirements, but these are just some of the main components. Here are some additional permit requirements. I don't have time to go into all of them, so please refer to this slide. And here are the groundwatering non-discharge limits. And I'm not going to go line through line, but feel free to look at the slides provided in the PowerPoints. And here is the surface water monitoring discharge limits. I don't have time to go line by line, but please refer to this PowerPoint for this information. Storm event parameters should be recorded every time a stormwater sample is taken, whether monthly or a quarterly sample. Samples should be taken within 30 minutes from when stormwater begins to discharge from each monitoring location. Listed here are the required minimum site-wide BMPs that must be implemented. Permittees can choose to implement additional BMPs to mitigate their pollutants and runoff controls, but these are the minimums. This includes site inspections, erosion and dust control, stream back stabilization, and others. And here are some details on the sampling procedures. And if you have questions on these, feel free to reach out to us. And now I want to cover some New Jersey BMP manual updates and other resources on our website. Earlier today, you were shown various chapters and dependencies for the BMP manual. These have been updated on our website, and here are the chapters. The chapter 12 was recently updated in March 2024. And as well, you can get any information for any of the permits on our Najipti Stormwater website. And if you have questions about the MS4 program, you can get those on the MS4 website. I happen to be the person that updates the website, so if you see any broken links or updates, feel free to email me and I will make sure to get those fixed as fast as possible.